Good day, everybody. I'm going to go over this time-tested technique that we use for a lot of times just when the coefficient is a real number. We have a coefficient that is a complex number, but we can still use this familiar idea. Let's just write it down in more general form here. Just call the coefficient of x b. Okay. Now, just through fairly basic algebra, this is very easy to show that x plus b over 2 quantity squared, and then we have to subtract off the mistake right here, folks. Very familiar idea. It's taught over and over in an algebra class. And y'all, this identity is just based on the fact that a plus b quantity squared is a squared plus 2ab plus b squared. And a simpler way of seeing it, if you don't like the longevity of that description, is just if you expand this out, b over 2 gets multiplied against x twice. That's where the b over x comes from, right? So when you expand this out, b over 2x happens twice, but that's just bx, okay? So this is the idea of very affectionately called complete the square. And we're going to use that simple idea here for this nasty looking coefficient. And you really only have to remember that I squared is equal to -1. You don't have to think about, oh no, this is a complex equation or anything. Just remember I squared is equal to -1. Okay? And you can see that this is already, I've converted this to something that's exactly in this form right here. This form that you see right here is exactly the form you see right here. You see how you have 43 here? Well, then you have half. Or do you have this number here? Call it a number, forget the I. Half of this number just is accomplished by putting a 2 in the denominator, you see. That's this 2 right here, okay? And then I wrote in the constant that's included in the original equation, all right? You can't leave that out, right? Now, I'm not carrying the 0 around. There's no need to, really. Okay, now, if you carry on right here, if you all the work that's really happening here is being done when you square right here. And when you square this term, again, which is the same as what's happening right here, okay, I squared gives you the -1 that you see right here. This -1 that's right here is the -1 right here, right? Okay, and then you go, oh no, we have to know what 43 squared is. No, we don't. This 43 cancels with one of them, leaving just one down here. Okay, so we're getting close to the finish line here. Now, all that's important to notice right here is that 4 times 43 is equal to 172. 4 times 43. That's the biggest calculation you have to do. Okay. And so this was already in a recognizable form if it wasn't a complex coefficient. It's not too easy to recognize it if you have a complex coefficient. But we get this perfect square. And remember, this is what we're trying to, all of this is equal to this, but we wanted to set all of that equal to 0, right? So we will set this equal to 0 down here. And then it's just trivial to see the solution here. X is going to be equal to minus this guy right here. Minus 7 root 43 I all over 86. Okay, so that's our answer. Complex number, folks. And really, in a way, if you can, if you're good with complex arithmetic, you just see the answer fairly quickly. You would have noticed at the very beginning that this is in the form. Now, it's not easy unless you have a little bit of practice, but this is in the form at the very beginning, a plus b, which is the justification for the complete the square idea to begin with. A plus b quantity squared is equal to a squared plus 2ab And hopefully this will help you remember some people memorize still this complete the square thing without really knowing where it comes from. But this is why it all works, right, folks? So if you would have looked at this, you could have kind of seen, it's a little hard to see, but you have to notice that 4 times 43 is 172, and then factor in the fact that I squared is equal to -1, okay? But all of this is all the same thing. This exists, this kind of idea exists just because of this identity. You have a 2 here, you have a half here, but it's really the same thing, okay? So, it's just written in a different way. Twice something, half something, there's a duality there. But in any event, this looks verboten, when you first look at it, but then you realize if you don't know where to go, it's in quadratic form. Try complete the square. This is called completing the square. And again, this is the solution. Thanks for viewing.